Hi, Assalamualaikum and a very good morning. So now we're going to do some tutorial discussion for chapter 9 and we're going to focus on the subtopic of 9.3 which is preparation of alcohol as well as 9.4 chemical properties of alcohol. We're going to do tutorial question 5, 7, 8, 9, 11, 12 and 13 respectively. So without any further ado, let us start. So for tutorial question 5, we have to give a chemical test in order to distinguish between benzaldehyde and benzyl alcohol. So benzaldehyde are basically benzene that is attached with the aldehyde group. So it's going to be written as something like this, which is the benzaldehyde. Meanwhile, for benzyl alcohol, this is known as the phenyl methanol, the other name of it. Okay, so methanol going to have CH3OH, right? Because it is a methanol. However, one of the hydrogen, okay, is replaced by a phenyl group. Okay, so this is known as the phenyl methanol or benzyl alcohol. Okay, so we're going to throw it again here. So the name is benzyl alcohol, or the other name is phenyl methanol. Okay, so now we need to give a chemical test in order to differentiate between the benzaldehyde as well as the benzyl alcohol. Okay, so you know that benzaldehyde is an aldehyde. Okay, they are the carbonyl group and it's attached with hydrogen, so it is an aldehyde. Meanwhile, the benzyl alcohol has a hydroxyl functional group, so it is an alcohol. So in order to differentiate between aldehyde and alcohol, we can do a tolerance test. Okay, so tolerance test will give positive result on the aldehyde. Okay, so the tolerance reagent will be consisting of the argentum NH3 2 plus at the basic medium, and this is going to give positive result on the aldehyde, which in this case is the benzaldehyde here. So as the product of the reaction, the silver mirror going to be formed. Okay, so we're going to do the equation here. So benzaldehyde, we're going to react that with the argentum diamine, and then this happens at the basic condition. So as a result of that, we're going to produce a carboxylate ion which attach to the benzene ring. Okay, so C double bond O, O minus here. Okay, and as a result, the argentum solid gonna be precipitated down, and this gonna give a silver mirror. Okay, they're gonna be other byproduct as well, for example ammonia and ammonium ion. However, the most important part for the identification test is the color of the argentum. Okay, now, okay, this one's the silver mirror. Now for the alcohol, we're going to react with the same reagent, which is the argentum diamine, plus here and plus here. And then it's going to happen at the basic condition. And this gonna not going to react. So we can say that it's going to be no observable changes. Okay, do not write no reaction. Okay, please write no observable changes because we are doing the identification test. So we need to be dependent on the observation. So kalau tiada perubahan, so we can say that no observable changes instead of no reaction. Okay. Now we're going to do the chemical test for 2-pentanone and 3-pentanone. Okay, so pentanone will have 5 carbons. So 1, 2, 3, 4, and 5. And then at carbon number 2, it's going to be a double bond here. So this one going to be 2-pentanone. And for 3-pentanone, going to be 1, 2, 3, 4, 5. The C double bond O going to be here. Okay, so let's draw that. So we have 2-pentanone and then we have 3-pentanone. So how can we differentiate between 2-pentanone and 3-pentanone? Okay, so both are ketone. So what we can do is that, well, we cannot do tolerance reagent because tolerance reagent gonna give positive result on aldehyde only. Okay, but for this case, both are ketone. So what we can do is we can do the iodoform test. Okay, iodoform test. where the iodoform test is going to detect the methyl carbonyl group. Okay, so we have looked about this in the chapter of carbonyl, and this is going to give a positive result for this structure here, or they can also give a result for methyl carbinol. Okay, so this one is carbonyl, so it is known as methyl carbonyl group. This one is OH, so it's going to give a positive result on methyl carbinol as well. All here refers to alcohol. Okay, so in this case, we're going to focus on methyl carbonyl. So we're going to look into the structure. Which of the structure here will have the C double bond CH3? Okay, so if I look into 2-pentanone, I'm going to have C double bond O CH3. So this is consistent to this. Okay. However, for this one, C double bond O CH2 CH3, CH2 CH3. So this one is not the same as this one. So this one going to give a negative result. This one going to be a positive result when tested with iodoform test. Okay. So what I can write here is that we can use iodine and NaOH, and this is going to give a positive test with the 2-pentanone, where this reagent here refers to the iodoform test. Okay, nama pun iodo, so it using the iodine. Okay, and it's used to detect methyl carbonyl in chapter 9 and methyl alcohol or methyl carbinol in chapter 8. Okay, so yeah, both can be used. Okay, so let's us do the equation for the reaction. So now 2-pentanol gonna react with the iodine in the presence of NaOH. So what they can do is that they're gonna produce a pentanoate ion or carboxylate ion, but specifically because it have 5 carbons, so it's gonna be pentanoate. Okay, and then it's gonna produce a yellow precipitate. Okay, so it's gonna be one, 2, 3, 4. So it's gonna be butanoate, butanoate ion because it's minus 1 carbon. And here the extra, we have 5 carbon here, 1, 2, 3, 4, 5. So here got 4, so 1 is being used here in order to form a triiodomethane, which is yellow precipitate. So you know that this compound here going to give a yellow precipitate. Okay, and as for tryptophan, when we react with the same reagent, which is iodine at basic condition, which is NaOH, there are going to be no observable changes. Okay, now we move on to the tutorial question 7. So we have to draw the structural formula for the product form when the propanal reacts with the sodium borohydride in aqueous NaOH. So propanal is a 3 carbon, and at the end here we're going to draw an aldehyde. Okay, so 1, 1, 2, 3. So at the end, which is the aldehyde, going to have double bond O and H. So it's going to become a propanal. Okay, so when it reacts with sodium borohydride in the presence of NaOH, what they're going to do is they will undergo reduction. Okay, so what's going to happen here is that from aldehyde, it's going to be reduced into alcohol, and it's going to be primary alcohol specifically. Okay, so what we're going to draw the structure again and make a primary alcohol. So 1, 2, and 3. So from propanal, it's going to become propanol. Okay, nal to ol, aldehyde into alcohol. Okay, and usually the sodium borohydride here will be in the solution of methanol. However, in this case, we are using the sodium hydroxide, which is still applicable for reduction. Okay. Now we're going to do the same structure here, which is the propanal, and then we're going to react that with a Grignard reagent. So nampak je C6H5 MgBr. So the keyword here MgBr, it refers to the Grignard reagent. So the R group here is a phenyl. Okay, so a phenyl group attached to the MgBr. So when they react together, followed by the process of hydrolysis, so this one is compulsory to write. Okay, what they're going to produce is a secondary alcohol. Okay, so here is propanol. So when a Grignard reagent react with an aldehyde other than methanol, so here is propanol, it's going to produce a secondary alcohol. Okay, so here going to be attached with this bonding here, and then you just follow up here, and then the double bond O will be changed into H. Okay, so 1 2 3, here going to be 1 2 3, and 1 going to be attached with hydroxyl group. Okay, now we move on to the tutorial question 8. So compound X here has the molecular formula of C5H10O. It does not react with the Fehling solution, but it can be reduced to an alcohol with the lithium aluminium hydride. Draw all the possible structure formula of X. Okay, so X just now will have a formula of C5H10. It does not react with the Fehling solution. Okay, so Fehling solution is used to detect the presence of aldehyde. So kalau dia positif, maksudnya kalau dia react, maksudnya dia adalah aldehyde. But in this case, it does not react. So it shows that the C5H10O here refers to a ketone. Okay, and it can be reduced to an alcohol with the use of lithium aluminium hydride followed by hydrolysis. Okay, number 1 and number 2 here. So when a ketone reduce to with a reducing agent, which is lithium aluminium hydride, what we're going to produce is an alcohol, which is a secondary alcohol. So we know that our X here confirmed to be a ketone. Okay, so it have a structure of C5H10O. So I know that I need to make 5 carbon. So 1 2 3 4 and 5. Okay, and I need to make a ketone, so let's say I make it at the middle first. Okay, so if I were to count the carbon, I'm going to have C5 1 2 3 4 5, 3 hydrogen, 2 hydrogen, 2 hydrogen, so 3 2 5 plus 2 7, and then plus 3, so 10, and oxygen got 1, so it is consistent. So maybe my first isomer going to be 3 propanol. Okay, 1 2 3 4 5. Okay, so we know that X is a ketone as it does not react with Fehling solution, and the first structure that it can possibly be is a 3-pentanol. Okay, the second structure that it can possibly be is, maybe I can change the ketone part here, I can change it into here. Okay, so or here. Okay, doesn't matter lah if you want to put it here or here. So if you were to put it here, you're gonna get it as 1 2 3 4 5, so it's gonna be 2-pentanol. Okay, so this one is first structure, second structure, and then maybe another structure that we can do is that we can bring our carbon chain into here so that we can get another structure. Okay, so let's draw that. So once I do that, so this is our third structure, which is we need to start numbering from here, 1 2 3 and 4. Okay, so it's gonna be 2 propanol and then 2 butanol because 1, 2, 3, 4. So butanol and at carbon number 2. So it's gonna be 2 butanol and the methyl group is attached at number 3. So it's gonna be 3 methyl 2 butanol. Okay. Now we're gonna do tutorial question 9. So we have to show how the following conversion can be carried out. So we need to show how propanol can be changed into propene. Okay, so propanol got 3 carbon, 1, 2, 3, and C double bond O going to be here. So this is a propanol, and then I'm going to change it into propene, which is like this. Okay, so what I can do first, I think I can change it into an aldehyde first. Sorry, into an alcohol. So what I'm gonna do is I'm gonna reduce my ketone into an alcohol. So I'm gonna use a lithium aluminum hydride, number one. So number one is compulsory, followed by hydrolysis. So number two here is also compulsory. So it needs to be step by step. Okay, so from a ketone, I'm going to produce a secondary alcohol here. Okay, and from here to here, I can do a dehydration. Means that I'm going to remove water. Okay, so the reagent that I need is the concentrated H2SO4, and this need to be happen at high temperature. So I'm going to remove the hydrogen here and OH here in order to make my double bond. Okay, so once I do that, I'm going to get my alkene, which is my propene. Okay, so this is how you show the conversion. Now for A2, the same structure, which is propanol. Okay, and now I'm going to make 2-chloropropene. Okay, so what I can do from here is that I can do my reduction again because alcohol is a very versatile reaction. So I can make an alcohol first, and then I can do nucleophilic substitution reaction where I use Cl and remove OH here. So yeah, I can use PCl3 or PCl5 or SOCl2 in order to replace my OH here. Okay, so that's the idea. So my ketone here, I'm going to reduce it again by using lithium aluminum hydride followed by hydrolysis. As mentioned, number here is important because it is done in stepwise, and then this is going to produce my alcohol, the same method as before. But now I'm going to produce a haloalkane. So I'm going to react that with PCl3, for example. Okay, so there's a lot of option. So you choose one. For example, I'm choosing PCl3. So when I'm using PCl3, my Cl going to be my OH going to be replaced by Cl. Okay, so this is how I convert propanol into 2-chloropropane. Okay, and now for 9b, I have the cyclohexanone. So cyclohexanone is as shown here, which is cyclic compound and then 6 carbon cyclic compound, and then we'll have a ketone here. And then I need to produce it to 1,2-diol. Okay, so I need to convert this one into this one. So what I can do is that I can undergo reduction. Okay, if I go reduction, I will get my alcohol. Okay, so maybe I will use different reducing agent here, which is NaBH4. Okay, sorry, and then this one need to be in methanol in CH3OH. So what I'm going to get is my alcohol here. Okay, so for my alcohol, because I need to attach with 2 OH group here, right? So what I'm going to do is I'm going to dehydrate first. Okay, so I'm going to use the concentrated H2SO4 so that I can produce my cyclohexene here. Okay, okay, so for my cyclohexene, I can use KMnO4 minus at basic condition so that I can attach OH and OH here. Okay, so that's the idea. So what I'm going to do is that I'm going to react with KMnO4 but at basic condition, yeah, not at H plus. If H plus is going to undergo oxidation, but OH minus here refers to the formation of diol, which is cyclohexane 1,2-diol. Okay, so that's for tutorial question 9. So for tutorial question 11, we have to complete the following reaction scheme and write the structural formula of A to E. We also need to specify the reagent of 1 until 3, which is 1, 2, and 3 here. Okay, so let us start with the letters first, which is A here. So in the middle here, we have the CH3, CH2, CHO. So this one refers to aldehyde. Okay, so if you were to expand or draw the skeleton structure, you're going to have CH3, CH2, okay, and then aldehyde here. Okay, so don't misunderstood it as alcohol. Okay, this is not an alcohol, this is an aldehyde. So it's going to be CH2 and CH3 here. Okay, so be very careful. Okay, and now for the aldehyde, it's going to be reduced using the lithium aluminum hydride and followed by the hydrolysis. So aldehyde is going to be reduced into alcohol, which is a primary alcohol. Okay, so we're going to draw it as CH3, CH2, CH2OH. Okay, so it's going to be 1, 2, 3, and then at carbon here, you're going to be attached with OH group. Okay, and okay, that's for A. Now we go and we're going to go down here, which is A going to 3. So OH, I replace it with Cl. So I can use PCl3 or I can use PCl5 or I can use thionyl chloride in pyridine. Okay, so this is the nucleophilic substitution reaction in order to replace the OH and place it with chlorine. Okay, so you can use either one, either PCl3, PCl5, or sodium sulfur dichloride oxide in pyridine. Okay, for the this part, so let us look into the aldehyde here, and it's gonna react with a Grignard reagent. So when there's MgBr, it automatically refers to a Grignard reagent, which is the MgBr followed by hydrolysis. So when a Grignard reagent reacts together with an aldehyde here, which is the propanal, what we're gonna get is a secondary alcohol. Okay, so what we're gonna get is the 3 carbon chain here, and then it's gonna add up with 2, 1 and 2. So it's gonna be 1, 2, double bond, OH, and then another ethyl group. So it's gonna be a 3 pentanol. Okay, so it's gonna be 1, 2, 3, 4, 5, and at carbon number 3, it's gonna be attached with OH. Alright, and then the alcohol gonna be oxidized into a ketone. So alcohol can be oxidized into ketone by using any oxidizing agent. So we can use KMnO4 at high temperature and at acidic condition, or we can use potassium dichromate at acidic condition at high temperature. Okay, all of this is compulsory to write. If you write it as K2Cr2O7 only, then it is wrong because it needs to be using this strong oxidizing agent at acidic condition at high temperature. So these all conditions are required for the oxidation to occur. Okay, so please be very careful so that you need to include all of these three. Okay, and now we're gonna look into the C and D here. So we have the aldehyde, and then we have the KMnO4 OH minus, high temperature, and then H3O plus. Okay, so basically here it refers to oxidation. Okay, as mentioned, KMnO4 need to have the acidic condition. Okay, but in certain cases, the KMnO4 can be in alkaline condition first, and then you add up with acid. Okay, so it conveys the same meaning, which is H3O plus acidic, because acidic is the latter step, so it happens at the acidic condition. Okay, not the basic. Okay, so aldehyde gonna be oxidized. So when aldehyde oxidized, it's gonna form a carboxylic acid. So you're gonna draw it as like this, which is a propanoic acid. Okay, so C double bond O OH the same, CH2 and CH3. And then this carboxylic acid here gonna react with CH3OH, which is a methanol, which is also example of alcohol. And then this happens at the condition of concentrated H2SO4, which acting as a acidic catalyst. So if you were to look at here, we have the carboxylic acid, we have our alcohol, so and we have our catalyst. So we know that it will undergo the process of esterification. Okay, for the alcohol, which is CH3OH, it gonna loses the hydrogen, and for the carboxylic acid, it's gonna remove the OH, and this gonna produce a byproduct of HOH, or known as water. And as the result, the CH3, CH2, C double bond O of the carboxylic acid gonna be attached with OCH3 here, and this gonna produce an ester. Okay, so the ester can be drawn nicely here as shown here. Okay, so this is your ester. Now we gonna look into the E part. So starting from alcohol uses K concentrated H2SO4 at high temperature, we know that it will undergo dehydration. So it's gonna remove water. Okay, so this is a propanol, which is 1, 2, 3, and then OH. And then we're gonna remove hydrogen and OH here. So as a result, we're gonna produce a propene, which is 1, 2, 3. Okay, so this is E. And then for our CH3, CH2OH, we can also change it into CH3, CH2, CH2Br. So we have few options. So we have PBr3, or we can use PBr5. Okay, the same as before, but then the Cl3 we change into Br. Okay, and SOCl2 is only specific for chlorine. There's no SOBr2. Okay. Okay, so now we have completed the reaction scheme for question 11. Now let us move on to the next question, which is tutorial question 12. So propanol, which is here, can be converted into various compounds as shown in the following reaction scheme through the structural formula of A, B, C, D, and E. So we have our propanol, and then when it reacts with the HCN, okay, so HCN is produced in situ. So CN gonna be reacted, gonna attack here, and this gonna push the double bond into carry a negative charge. So the negative charge going to be attached with hydrogen, and hence the Cn going to be attaching, and this is going to produce a hydrogen OH group here. Okay, so what we're going to draw is to be something like this. So Cn making a bond, and the double bond O become OH here. Okay, and now when it undergo acidification, okay, what we're going to do is this one is known as the cyanohydrins. So when it is acidified, the Cn here gonna be forming a carboxylic acid. So Cn here gonna be changed into COOH, as shown here. Okay, now we're gonna look into structure C here. So here is a ketone. When it react with a Grignard reagent of MgBr, so what we're gonna forming is the tertiary alcohol with a structure of like this. Okay, so you can draw it CH3, CH3, CH2, CH3, which is the same, and then it's attached with OH, which is a tertiary alcohol. Okay, because Grignard reagent react with a ketone, gonna produce a tertiary alcohol, and this tertiary alcohol will be able to undergo dehydration using concentrated H2SO4 in order to produce minor and major product. However, the question stated that D need to be a major product. So OH, and we can remove H, OH here, OH here. Okay, so what we in order to produce a major product, we're gonna select the most substituted alkene. Okay, so OH, and then we're gonna remove H from here in order to make a double bond here. Okay, so I'm gonna do that. So what I'm gonna get is C, C, H, CH3, CH3, and CH3. So it is attached with 3 alkyl group. Okay, if I were to remove hydrogen, not from this side but from this side, okay, what I'm going to produce is C double bond C, CH2, CH3, CH3, H, H. So if I were to remove on this side, what I'm going to get is 2 alkyl group. Okay, so the 3 alkyl group is more stable because it's a more substituted alkene, and this is going to be the major product. So the rule for this one is based on the Side-Zeth rule. Okay, so A, B, C, D done, and then we need to do E. So we have our ketone, and then we have our lithium aluminum hydride in ether, followed by hydrolysis. So ketone can be reduced into alcohol, which is a secondary alcohol. So it's going to be CH3, CH, OH, and CH3. Okay, so this is known as the 2-propanol. From propanol, it becomes 2-propanol. Okay, so that's the reaction scheme for the 12A here. Now we're gonna do 12B, which is what is the rule in order to use to predict the structure D here. Okay, so this is the structure D. So structure D is based on the Side-Zeth rule. Okay, and if you were to write the structure, ensure that you put the label. A is equal to this structure, B is equal to this structure, E is equal to this structure, D is equal to this structure, and C is equal to this structure. It is important to do the labeling. Okay, Now for 12C, one of the chemical tests that can distinguish D and E is by using Br2 in CH2Cl2, which is the dichloromethane, which is the inert solvent. We have to state the observation and write the chemical equation. So D is the alkene and E is an alcohol. So D is an alkene, and so write D here, and then this one E is an alcohol. So when alkene react with the bromine molecule in the inert solvent, what we're going to do is that the Br going to be attached here and Br is also going to be attached here. Okay, and this gonna make our observation to be reddish brown color of bromine decolorized, because the bromine color, which carries a reddish brown, gonna break apart in order to form a new product here. However, when an alcohol react with bromine in inert solvent, there will be no observable changes. So what we can say about the observation is that the reddish brown color of the bromines remains unchanged. Okay, and for last question of 12D, we have to state the type of the reaction involved in the formation of E. Okay, so from a ketone become alcohol, it is a reduction type of the reaction. Okay, so before this in chapter 4, you have learned about addition, substitution, elimination, rearrangement, and for reduction is also another type of reaction. So for this case is a reduction, which is a new type. All right. For tutorial question 13, compound W and X have the molecular formula of C8H8O. W will react with hot Fehling solution, produce a red precipitate. X give a negative result towards Fehling test, but it reacts with lithium aluminum hydride followed by hydrolysis to form alcohol Y. Both X and Y will react with iodine in sodium hydroxide solution to yield a yellow precipitate. Okay, kalau baca macam ni confirm tak faham. It's very wordy. Okay, terlalu berayat. So what I'm going to do is we try to read it section by section. So you know that compound W and X have the same molecular formula. So write it first. So more general formula or the molecular formula is C8H8. So both W and X adalah sama, which is C8H8. However, W react with hot Fehling solution, produces a red precipitate. Okay, so Fehling solution, W will react. However, X will give the negative result toward Fehling test. Okay, so X akan memberi negative result. For W, it's going to be a positive result. So Fehling solution is used to detect the presence of aldehyde. So when it is positive, means that the structure here to be aldehyde. Meanwhile, the structure is X here going to be a ketone. Okay, so we have a formula of C8H8O. So you know that from here, it cannot be a open chain alkene like this. It needs to be with the benzene ring, because from here we know that it already uses up C6H6, and then we need to add another bond in order to make it here. If this one 1 2 3 4 5 6, we're going to end up with C6H14 already. So it's really hard to make it as like this. So we know that we need to have the benzene ring in our structure. Okay, so sorry, let me try it again. So we have our benzene ring, which is C6H5, because one of these I'm going to do a chain here. So I know that my W gonna be an aldehyde. So C6H5 now. I need C8H80. So I need to add with another C2H3O. So I need to add up with 2 carbon, which is 1 and 2. and for aldehyde it's going to be at the end. Okay, so 1 2 hydrogen, 1 2 carbon, hydrogen 1 2 and 3, oxygen 1, which is refers to this structure. So you know that W gonna be this one, where if you were to count, you're gonna get C8H8O. 1, 2, 3, 4, 5, 6, 7, 8. And then hydrogen got 5 in the benzene ring. 5, 6, 7, 8. And then oxygen got 1. So C8H8O. So I know that my W gonna have this structure here. Okay. And for X, I know that it is a ketone. So what I'm going to draw is benzene ring and then try to make a ketone 1 and 2. So this is going to be my X here. Okay, so by knowing this information, it will make me easier in order to make up the next step. Okay, and let us read the next line. So X give a negative result towards Vehling test, but it reacts with lithium aluminium hydride followed by hydrolysis to form alcohol Y. So we know that X will react with lithium aluminium hydride followed by hydrolysis to form alcohol Y. Okay, so from a ketone, they can undergo reduction in order to form a secondary alcohol. Okay, and this is our most logical structure for the alcohol here, so which is the alcohol Y. And then it says that both X and Y react with iodine in sodium hydroxide solution to yield a yellow precipitate. So this refers to the iodoform test. Okay, so iodoform test is used in order to detect the CH3COH H bond, which is methyl carbinol, and also used to detect methyl alcohol. Okay, so in this case we have COH CH3H, so it's gonna give a positive result. Here we have C11O CH3, so it's also gonna give a positive result. So we know that our structure here is correct because it is consistent to the information here. Okay, so this one is for iodoform, so let me erase that. Okay, so now we have done with the drawing of structure W, X, and Y. Now we have to give the product of the reaction between W and lithium aluminium hydride. So this is a reduction, and W with acidified potassium dichromate solution. So this is an oxidation. Okay, so we draw W again, and then we're going to react with lithium aluminium hydride followed by the hydrolysis, and this is going to produce a primary alcohol here. So this is an aldehyde. So aldehyde going to be reduced into primary alcohol. At the same time, the W going to react with the potassium dichromate at acidified condition at high temperature in order to produce a carboxylic acid. Okay, so these are the reaction for the question 13. So it uses up much of your information from chapter 8 and also certain information from your prior knowledge. Okay, so I think that's all for today's video. See you again some other time. Bye.